Through innovation, academic excellence, and family-centered clinical care, Children's Mercy Kansas City is transforming outcomes for children around the world. Welcome to the audio interview series, Transformational Pediatrics, with host Dr. Michael Smith.
So our topic today is Bench to Bedside, research focused on improving BPD outcomes. My guest is Dr. Venkatesh Sampath. He is a scientist and neonatologist at Children's Mercy Kansas City. Dr. Sampath, welcome to the show.
Oh, welcome. Thank you.
So what have we learned so far about the how and the why behind premature infants developing BPD?
Right. So I think the last 20, 25 years, we've learned a lot of new information. In the 90s, early in the 90s, when the tiny babies were surviving and getting BPD, the traditional thought was that a lot of oxygen use and being on the mechanical ventilator, the artificial breathing machines, was the two most important cause of premature babies getting lung disease. And to a large extent, we've been able to mitigate those factors. They're still players now, but with the way we artificially ventilate these babies is much more gentler, and how much oxygen we give to these babies is titrated very closely. So with those measures, we've been able to, we saw a decrease in BPD rates in the 80s and 90s. But subsequently, in the last 15 years, we have not been able to make much progress. And that is because I think the survival of the tiny babies has improved. So more babies are at risk of developing lung disease. And the other factor is that the one which I'm particularly interested is understanding how lung inflammation caused by infections directly in the lung or infections in the bloodstream cause BPD. And I think since BPD is a very complex disease and multiple factors are involved in causing the disease, the things that we can decrease, the factors like increased oxygen use and artificial ventilation, those I think we have made a lot of progress. But there's other areas, other risk factors which have cropped up in the last 15, 20 years, which we are addressing, but they seem to also have become very important players for causing the disease. And also particularly because a lot of the small babies are surviving, and because now we have new survivors, a lot of them are at risk of lung disease. So I think what we have learned in the 80s and 90s was that oxygen toxicity and artificial ventilation can injure the lung. And to some extent, we have made a lot of progress on that. More recently, by which I mean that 15, 20 years, what we beginning to understand is that infections, either directly in the lung or in the blood, can affect lung disease pretty badly, can cause lung disease badly. And also, genetics also plays a major role. So I think the focus right now in the last 15, 20 years has been going towards infections and the genetic basis of lung disease. So I think we have learned a lot, and to a large extent, we have mitigated some of the risk factors. But since BPD is a very complex disease, we are unearthing new information which needs to be dealt with to decrease the rates of BPD further.
Right. Well, let's talk about the infections that you mentioned. So exactly what has been the theory or the hypothesis of how these bacterial infections are affecting the developing lung and vasculature in premature infants? Right.
So that's one of my pet peeves, because what I've noticed when I was in training and as a fellow in Cincinnati and immediately after when I became faculty, that I would see these babies who would not be ventilated for too long and did not have much oxygen for too long, but they would get just one or two infection episodes, and then they would get this disease. So obviously we found I was really interested in dissecting that role of infection in lung disease. And so what we think currently is that whenever babies get an infection in the bloodstream, and because they're premature, they have an unregulated immune system. So what happens when they get infection is that though you treat them with antibiotics, the infection and the body's response to infection creates a huge inflammation in the lung. And in adults, this is seen as acute lung injury or ARDS. So we see a similar picture in some preterm babies who get infections. And because of the acute inflammation in the lung, what happens is that the lung is injured. And a lot of them during this inflammatory process, a lot of proteins are secreted which digest the lung, in fact, and also cause injury to different cell types, increasing the endothelial cells or the epithelial cells. And those also can result in BPD. My specific focus has always been on the lung endothelial cells. And the reason we are very interested in those cells is that how does an infection in the bloodstream cause inflammation in the lung? What's the connection? And I think one important connection there is the lung endothelial cells, because the endothelial cells senses this inflammation, and the lung endothelial cells secrete a lot of molecules which attract the inflammatory cells into the lung. So they inadvertently, in trying to fight the infection, the lung endothelial cells are also pulling these inflammatory cells into the lung tissue, and that sets up this whole inflammatory cascade which contributes to BPD. The other important part of that same story is that the lung endothelial cells, when they get inflamed, they behave differently. Normally, they do the usual thing. They grow, they maintain the integrity of the lung vasculature. But when they get inflamed, they do other things, and they affect how new blood vessels are formed. So when lung endothelial cells get inflamed, they have a propensity to form abnormal blood vessels. And we know that in babies who die with BPD, the vasculature is very abnormal. So my interest in studying how this endothelial cells gets inflamed and how that endothelial inflammation contributes to inflammation in the lung, but also contributes to abnormal vascular formation, which is seen in babies with BPD. So that's really my focus.
So this is fascinating, right? So you found that there's this connection between the infection, the dysregulated immune system in the premature infant, and there's a release of these cytokines, these pro-inflammatory compounds. There's a direct insult onto the endothelial lining itself, but at the same time, that's causing a abnormal angiogenesis in the lung. So you've made this nice connection all the way. So where are you at in all this research now? I mean, how far you've put together this wonderful hypothesis and this very linear connection? Where are you at in all that?
Yeah, I'm glad you asked this question because we're really excited. Our lab, I have to thank my lab members for doing this great work. But the first step was actually showing that a lot of clinicians knew this kind of thing existed, but we wanted to prove in a mouse model that this existed. Typically, if you look at a lot of animal models of lung disease, we need animal models to study lung disease. And they've used a lot of oxygen toxicity or ventilation in rodents or in bigger animals, in sheep, for example, or lamb, to cause lung injury. Mm-hmm. So we first wanted to ask a simple question. If my hypothesis is correct, can I create BPD or something similar to that in the mouse without using the typical risk factors, which is the oxygen toxicity or the ventilation toxicity? So we just published a paper in American Journal of Respiratory Cell Biology, which showed that if you just give in the neonatal pup, if you give one dose of LPS in the peritoneal space, which just mimics the sepsis or an infection, one dose or two doses, just that, no oxygen toxicity, nothing else, that alters lung development with less vessels and less alveoli. So that is the proof of concept paper.
We know that the LPS, too, just to bring it back for a second, the LPS is really strongly pro-inflammatory, right? So that's making your connection between, going back to that original thought, that the infection and the inflammatory response is really what's underlying all of this abnormal angiogenesis down the line, right? So that is your proof of concept, correct? Yeah.
That is my proof of concept because LPS, as you correctly pointed out, is derived from gram-negative bacteria, and gram-negative bacteria are one of the worst pathogens in babies. A lot of the babies who get that die, but a lot of survivors will get bad lung disease. So we took a component of that LPS, which is derived from gram-negative bacteria, showing that in proof, this LPS derived from bacteria can, in the setting of a developing animal, in the setting of the developing lung, can injure it in such a way that you get abnormal lung development, abnormal blood vessels causing BPD. So that was, I think, the first, because we want to first prove that our hypothesis is correct, and we can develop a mouse model to prove it. So subsequent to that, then now I think what we are doing is we are playing it in two different ways. We are trying to understand what are the normal mechanisms which keeps endothelial cells intact and how those mechanisms are altered. So important clue that we are finding out, and we're really excited about it, and we're hoping that in 2017 we'll publish a key paper on this, is that it looks like when the lung grows, like every other organ, you need angiogenesis for normal lung growth itself. So there's some master regulators of lung growth called delta-like 4. It's just a gene. It's a very critical gene, and that regulates lung growth. And what we are finding is that LPS can alter delta-like 4 signaling. So we now have come to the second line of proof, which can we show a relationship between inflammation and endothelial inflammation and bacterial sepsis, and how angiogenesis mechanisms which control how blood vessels develop are altered. And we haven't published yet, so I don't want to make too much of it, but our data are very strong, and I'm hoping that will come out in 2017. That we can show there are very critical angiogenic mechanisms which are altered with LPS or bacterial products.
Well, obviously, so Dr. Sampath, when you make that connection, right, and you prove your hypothesis here, because now when I step back and I look at this, starting with the bacteria, ending with the abnormal angiogenesis, what you're laying out are many potential targets for treatment now. Early on, and of course, because that's really what this show was about, was how are we going to improve outcomes in BPD, and so you've laid out a nice theory of how this all develops, and I already see it in my mind. You have these potential areas that you can target to to treat and really make the outcomes improve for these. This must be obviously a very exciting time for you right now.
Right. I mean, I think it's an exciting time. And I must say that one simple way we can do this, even before we try new therapies, which everybody does now, is that if you decrease infections, bloodstream infections, that's going to have an effect itself. But despite our best intentions, some of these babies are going to get infected. So if we understand the molecules which are involved in this, let's say that in this pathway which causes lung abnormal blood vessels, then there are molecules. For example, angiopoietin-2 is a key molecule in the middle. And so we have targets, antibodies against that, which can potentially decrease the whole cascade and prevent BPD.
So lots of biologic agents, Yeah, that's great. So I just want the listeners to also know, Dr. Sampath, that you were awarded a 5-year grant by the National Heart, Lung, Blood Institute to study the role of inflammatory angiogenesis in the developing lung. So I just want the audience to know that. And this is fascinating work. It was great having you on the show, and I want to say good luck to the rest of your research. So thanks for coming on the show. You're listening to Transformational Pediatrics with Children's Mercy Kansas City. For more information, you go to childrensmercy.org. That's childrensmercy.org. I'm Dr. Mike Smith. Thanks for listening.